Okay, for people joining this meeting, this is one of 3 live stream design reviews for today. It means there's a new version approaching. And we are talking about NetFunction, which is a way of injecting more code-like code into neural nets. So please, reminder, let's go through the reminder. I need a reminder. No.
No what?
Well, okay, hold on.
That seems pretty uncontroversial to me, but...
Okay, hold on. So the idea is, and why is this not called function layer?
Would be called function layer.
Layer is a bit abused, like NetGraph.
It's going to be,
stuff.
Yeah. I mean, this is for simple stuff, but it's also more complicated things, and it will
What does it do that isn't a layer?
I mean, NetFunction. NetChain is a layer. NetGraph is a layer. They are the same thing.
I understand that. I just
special.
don't want to sign up for that much because I think NetFunction has the potential to be something much bigger.
I agree.
It is, yes.
Okay.
Well, it isn't yet because we don't have a good design for it yet. I'm pretty sure it should be called function layer.
Wait.
The point is that this thing can create many layers inside it.
Yeah, exactly. It's going to be sort of a container as well. So that's differentiators with other regular layers that have nothing inside them. They're always the lowest level.
What is NetTap?
Well,
Please don't do that. Please don't do that. Get rid of that.
Maybe it was a candidate for Nodify.
No. It was. I think it was for Echo, but it was a long time ago. I don't know why it's there.
Ah, right. Okay, sorry.
This was just a copy paste of some thing for reminder and just NetTap. There.
Okay, so I don't understand this. I'm sorry, I don't understand this. This function is being fed. How does it know what its parameters are?
In that case, there's no parameter. It's just a linear layer.
No. What hash foo, hash bar? What are those?
Oh, these are the inputs of the function.
Yes.
Oh, I know, but how does it know that?
Something is missing in the code here. Normally, function has the first argument, which are the variables.
Yeah, but that's not right either because this.
Why?
No. Look.
No,
This is a function. Yeah,
with hash, you don't need it.
You don't need it, right? You're just putting in here.
Yeah. Sorry. Yeah.
Okay. So this is expecting, but NetFunction is not telling you it's expecting that.
No, same as function is not expecting.
Right.
Function doesn't do either. So.
Right. Okay. Fine. So this is like Cloud Function in the sense that it takes a function inside it and is a thing that then applies that function. Is that right?
Yes.
Yeah.
Yes.
In the context of the framework, of course.
No. Don't care about that. That's an implementation detail which we don't discuss as part of the design.
We have to discuss that has to be part of the design because it has to be a citizen of the framework. It has to have, it has to work together with all the other framework's parts. It's not an implementation detail.
Okay, then I would like to know the precise specification of what you mean by that.
Okay, you can see that a bit further. So, I mean, yes, yeah. I mean,
this smells like a hack to me.
No. Okay, if there is one input, one output, it works exactly the same as another function. So if you go at the very top with the example.
Whoa.
Yeah. Okay, if it's like one input, one output, NetFunction sort, it works like the function. You just give the list, it will sort.
Yeah, okay.
And the only question that arises is when you have multi-input, multi-output, and there's two sections.
No. Then it has only one thing it can do. It has to work like function. It kind of has only one thing it can do. If it does anything different, it's a total hack.
Okay.
That's it. That's the story. Now,
well, the thing is,
okay,
yeah.
If you want to change that, you could conceivably have a second argument to NetFunction, which is a preprocessor that packages whatever it's getting in the form that will be fed to the function.
Well, what you have on the screen now, Stephen, I think it still works like function.
It does.
This one, yes.
Yes.
This one,
Because
yes.
All of this stuff works like function.
Yeah. It's the only one that doesn't work like function. The only one is multi-input when the input are not named.
Okay, and you're using hash1, hash2, hash3, aren't you?
If you do this, this.
Okay, so that's a hack and you can't do it.
Wait. What are you talking about? Let's go to the section multi-input. So multi-input, if you have named argument, this is
fine. That's fine.
Exactly, that's fine. When you have
fine.
Exactly, when you have inside is a valid function, that's absolutely no problem with that. The only problem is that we cannot give several arguments.
So let's understand what you would need to give here for this to work. This has to have some kind of currying thing, right?
It's
so what you're wait. What is it exactly?
It's Splice. I think it's called Splice now. Sequence at.
No, I don't think that's good enough. Right, that's not good enough. Let's write out the code that it has to use. Okay, so the thing is being given a list, X, Y, Z. Okay, now you're going to have a function f, but you want to feed that. So really what that is just f at that, right?
Yeah.
Am I making sense?
Yep.
So really what this is doing is this is really equivalent to, I think, this is saying this is really apply this, is it not?
Yes.
The alternative, which would also work, is to say, oh my God, they didn't fix this. They didn't fix this bug, the selection bug.
The selection.
Okay. Oh my gosh, it isn't fixed.
Well,
it's not
maybe
fixed.
Maybe it is
5 days ago.
an old layout.
Okay. Okay, so let's go through this again. So the alternative here is you can do this, right? And that needs to also work.
Yeah, this will work, no problem. This is a one argument function.
Right. So you're trying to do the other case as well.
For convenience, I think that's,
It is nice, I agree. But I think that this thing that I've given with an apply is okay.
One question though, how can they both work?
What do you mean, how can they both work? They're doing the same thing.
No, I mean the first and the third.
They cannot. This one will not work.
Oh, okay.
Will not work. It is a hack.
All right.
So It's
Don't
dead.
make that hack. Amusingly enough, I had exactly this hack in SMP. It was a disaster. How about we avoid it?
I think I also ran into something similar once when I was writing a parser for selection stuff. Yeah. Jerome, do you have strong opposition?
I mean,
it's not going to
that's-
happen, so there's no point in even discussing this.
yeah,
Okay.
but that's related things.
It's not going to happen.
Okay.
So now, whether this works is a different question.
That's weird as well. It seems very hacky to me as well.
Well, I don't think it's quite right. I mean, what this is doing,
It's two
hold on.
functions inside. So how many ports does it have? Like the nice thing, it has to be 2 ports.
Well, what you're trying to do is detect how many ports it has. Is that correct?
That's one thing you want.
Hold on. I want to
NetFunction.
understand. Disclosure, please. Does this function need to be able to deduce from its first argument how many ports it has? Can you answer the question, please?
I think so.
Okay, so that's going to be a hack, right? And that's the smelly hack that you're trying to put in here. Can you surface that, please?
We can also say that. I mean, okay, I'm not sure you want. We can also say that there's no named numbered argument. It's only named, and we have no problem ever.
That's not right either. It's still a hack. You have to go into that function. You have to go into the function. It's only going to work lexically.
Isn't function doing that? Like
yeah, of course.
Is taking an arbitrary number of slots.
Yeah. This is completely determined, which are the input of the function. The input of the function, the argument of the function are the ports.
Okay, hold on. Let's be clear here. This function, okay, ordinary function, you feed it 7 arguments, it takes 7 arguments. The innards of functions don't work with 7 arguments, it gives an error. Do you understand what I'm saying?
Mm-hmm.
We have no mechanism to ask function, how many arguments are you expecting? See what I'm saying? Not the nature of what function does.
Okay, so you're saying it's just a runtime issue, not when you define
well,
it.
Okay, but what you're trying to do here is to hack that. You're trying to go into the function and find out how many arguments it's expecting, right? Can you, Matteo, can you please explain that? Is that correct? I just want to clarify it.
I mean, I think Jerome is writing the function, so
okay.
we can.
All right, Jerome. Is that correct or is that not correct? That you are trying to go in and examine the function to determine its argument structure, correct or not correct?
Yes, correct.
Okay, so that will not work in general. So you understand that it will only work lexically here. If this thing has a hash that it passes to some lower function, it will fail. Am I making sense?
Yeah.
Okay, so
I mean,
this is not good.
The double hash can work. The thing that is difficult.
No, it cannot.
Is
Go ahead.
Is the hash with the number after that?
I see. Well, okay, but in any case, this is a hack. We surfaced a hack here.
We could remove the %, and this is just like another function.
No, that will not work. That will not work.
Because function has a mechanism, right?
No, function does not have a mechanism.
No, I think no.
It does not have a mechanism. It does not do that.
No, I mean, the big difference here is that function is purely symbolic and doesn't have to evaluate anything when you define it.
Okay,
this one
so listen,
has to compile to something.
The obvious thing to do is there's a second argument which gives the signature. Right. So what have we done in other cases where we have a second argument? I'm telling you, this is not the right name for this function. We are not ready for this function. This function at best has to be named defensively with something. This is not the right name. This isn't the right thing.
Because you think it's not going to be developed enough to deserve
That's correct.
this name?
It's going to be too hacky. And what's going to happen later on when we have essentially code that is turned into neural net operations, we're going to want this kind of functionality for code. See, this is close to that, but it isn't that. Am I making sense?
Yeah, I mean,
can we at least get rid of the
Okay,
second
so
argument
here,
from the
look,
string
you've got exactly this hackery in this case, haven't you? Input ports is exactly the hackery of saying what, you know,
Yes.
what is being fed in, right?
Yes.
I'm telling you, this should be called function layer and it should work the same way. And eventually we will have something that is actually called NetFunction that really does the right thing. And I don't know exactly how it'll work. It might have type arguments like in the compiler or something else.
Okay, I'm fine with function layer. Yeah, I'm fine with it.
Okay. Well, so then let's look at, if we do that, then it could potentially have this same kind of, whoa, what's happening next here? Okay, that it could potentially have input ports, output ports specified like this. Am I making sense?
Mm-hmm.
So the function is simply fed, you know, if it's going to be this case here, where you know, I mean, basically input ports is going to tell outer things what shape the stuff that's being expected in here is. Do you see what I'm saying?
Yeah, but
Yeah.
still in many cases we can probably get without it, like the one with Bob and Claire, for example.
I don't think you can, but I mean, you can try. I think it's going to fail most of the time. But I mean, if you say input ports are automatic, it could go and try and do an investigation, so to speak. Do you see what I'm saying?
Yeah. I mean, you could also do the investigation if you don't say automatic and your function is wrong. It has mismatch.
That's its prerogative to go and check up on you.
Yeah.
I wouldn't do that, actually. I would just dumbly feed the stuff in. And because I can imagine a case. Let's imagine, no, this is so broken. Guys, come on. Look, the flow of the network could involve another thing being passed in here, but the function was just changed because you're debugging something and you removed one of its arguments. In other words, it no longer had that dependency. But the structure of the network still has two wires coming in, except one of those wires, the input was ignored. Do you see what I'm saying? And if we were to just change the innards of the function and it auto-magically dropped the wire, it would be very confusing.
Well, it could just fail if the number of input ports in the option does not match the number of the...
No, that's wrong. That's not what you want. Think about the case I just described, right? You change the innards of the function, but you don't want to change the structure of the network.
But if there is never a point in which you want to do that. If you want to change the function, you want to change the network. Like, why would one want to do that?
Because
by convenience, like it's already inside a network, so
yeah.
But
you don't want to change it.
We are not even able to represent a port that goes nowhere.
Yeah.
Why not?
I mean,
it just
because
gets ignored by the function. It should work. You feed in the port, but it doesn't happen to select that element of the association. The function is independent.
Oh yeah, but this is already the case.
I know, but I'm saying, but with your auto magic stuff, it will fail.
Yeah.
See what I'm saying? It will not correctly pick the right keys.
Yeah.
This is going to be fine. This input ports thing is going to be fine. If you say automatic, which could be the default, you know, it'll go and auto-magically try and figure out what's going on, and sometimes it will fail. Make sense?
Mm-hmm.
Yeah.
Okay, so now, okay. I'm reluctantly agreeing to this thing here, input ports and output ports. I think we discussed that a previous time, didn't we?
Yeah, for compile layer. Actually, the head is compile layer here. There are several places where...
Well, I'm sorry, what head is compiled layer? The head here is compiled layer.
Yeah, I just copy-paste from some compiled layer notebook.
I know, but I'm glad I'm seeing that, because that's input ports would be used in compiled layer, correct?
Yes.
And so it's also being reused in function layer.
Yes.
I like the name function layer so much better. It signs up for so much less.
Mm-hmm.
Okay, so let's go through now. So it has both input ports and output ports, right?
Exactly. Exactly.
Okay, so let's understand what it does. Given that you've specified the input ports, what happens then is that sequence of input ports is given as successive function arguments to the function, correct? So if I say input ports, for example, let's say I say input ports arrow, I don't know what this is. If I say 2 here, does that mean that I've got a list 1, 2, or is it, what does that mean?
That means you will have 2 ports with automatic naming. So for example, they will be named input 1 and input 2, and they have unspecified shape.
I don't quite understand that. Okay, so then inside the function, I would be hash input 1, hash input 2, correct? That's what I would be doing. Is that correct?
That is for Jerome.
I mean, we can decide. It can be 1 and 2, input 1.
No, it cannot be 1 and 2, because 1 and 2 can't be done that way. If you do 1 and 2, if it's a string, is it a string, is it a number? Do you understand what I'm saying?
Yeah, so currently, if you use in the function slot input 1, yeah, it will create an input port named input 1.
I'm sorry, Jerome, you're really hard to hear.
Sorry.
He said that, that input 1 is correct.
Yeah.
This one here. This thing here, is that right?
Yes.
Okay, that's okay. I mean, it's not beautiful, but it's okay.
And slot 1 would also work, but it will take the first one in the canonical order.
That's fine. Because what this is being fed in reality is input 1 arrow X, input 2 arrow Y, right? And what you're saying is that part 1 of that is just X. So that's fine. So, oh, no. Hash 1 will not work. Look at this. Hash 1 will not work. Right? This is an association. Because the only way hash 1 works is if you fed the function those var_args arguments, not a list. See what I'm saying?
Not sure.
No. It doesn't work. That's what we just went through up here. Does not work. Right? If it's a list, it does not get its elements from hash 1 and hash 2. Do you see what I'm saying?
Yeah.
Okay, so this is the only thing that can work in that case. Unless we make a different decision, which I don't think we can make. I don't think we can do it. That allows, no. I mean, the fact is, feeding this case, the case hash 1 is not the same as the case hash name, which indexes into an association. Do you get what I'm saying?
Yeah.
So, okay, so this case, we could, unlike what is being said, we could make this actually feed it essentially a splice. Am I making sense? I don't think that directly works. I don't think you can feed a function a splice, although it's an interesting possibility that you be able to do that. In other words, if I have a function that expects a list, I mean, it's an interesting idea that you could feed it splice X, Y, Z.
No, but is it the opposite way around? So this is a function that expects a sequence and gets a list, and you splice the list.
No, but the function expects a sequence. So just like
Okay.
this is an example of such a function. A splice X, Y, B, right? That function expects a sequence there, but you've given it a blob, and that blob is the splice, right? So let me think about this for a second. So let's imagine, that's an interesting idea, that a function
But wait, how do you differentiate between? I mean, the point is that Splice only evaluates inside list.
That's correct.
And I think there's a
Well,
so in the case above, you will it will auto evaluate before being passed to F, or F will automatically know. What
I'm sorry. In the case of which?
You have one above, F of Splice XYZ.
Right, but what I'm saying is we could extend the domain of Splice to include function argument passing.
But then basically makes it like it works with any head, which I think was people were very opposed
No, I don't think it does. I don't think it does, because this, oh, I see. You're saying, okay, the question is there something you can feed into F so that, okay, so does there exist a function, mystery function, QQQ, of XY, such that that is F of XY? Does there exist any such function?
Apply sequence. As a head, it with the carried form should even work probably.
Right, but that's the wrong thing. That's apply sequence is an old hack.
Well,
right?
I don't think anything else exists.
Well, so then we maybe want to think about this, because this is the case you're talking about here, right? I mean, this is a more specific case. And by the way, ETS on our live stream has talking about, can you disable splicing? Splicing only works inside lists, which are inert. So there shouldn't be a problem. I mean, this case is probably wrong. So I'm retracting this case, because that could do all kinds of crazy things. But you see this, okay, so the issue is, I mean, this is similar to a currying operation, right? So if I say, for example, you know, let's do a headdress thing, reverse applied F XY, right? That does that. So what this is doing, it's almost like this headdress could do this. See what I'm saying? Now, actually, that's kind of stupid.
But that's already apply, exactly.
Just apply.
We have rediscovered apply.
Right.
But the point is that you don't want to start from the head. Yeah, your thing was starting from the arguments.
Mm-hmm.
But this is not much. I mean,
right. The question is, can you have an argument bomb effectively that a self-unfurling collection of arguments?
But do we need it just to use hash1, hash2? I mean, the point is, maybe, as you said, this is more limited in scope. So the point is, this is already very, very useful as it is in terms of easiness of writing complex.
Right. The fact is that if all you do in your examples of function apply, you put an apply. Look, let's write function layer, right? So function layer, let's write one. Function layer of apply f of hash1 plus f of hash2. Okay? Then we're good. It's just going to work, if I'm not mistaken.
No.
Am I confused? What's that?
No. I mean, this is it should.
Let's look.
Yeah, I mean, yeah, you can just apply it to the list.
Oh no, it doesn't work. Okay, hold on. Oh no, it doesn't work. It doesn't work because the function goes all the way inside.
Oh, you wrote apply. You wrote apply inside, not outside. Yes, no. Apply has to be outside if you want to use it this way.
Right.
It has to be addressing for the whole function. Not
yeah. Right. So this has to be like this. Okay, so here, this will perfectly well work. That will work just fine. Okay, so what this is saying is, if you want to use hash1, hash2 inside function layer, you've got to have an apply in that first argument, right? Otherwise, just with input ports, when you specify the input ports, okay, the only other possibility is that the input ports have a specification which causes you to have vararg stuff be fed in. Jerome, you understand?
Yes. Sorry, yes.
Yes, do you understand?
Yep.
Okay, so let's go through it again, right? So if input ports, so what are the requirements? Input ports must know what the argument structure that is being expected by that function is for two reasons, okay? It has two reasons to know that. Reason number one, it's external knitting of the function layer, right? Correct? Is that correct?
Yes.
Okay. And reason number two, internally, because it needs to know exactly what package to feed to the function that is the first argument. Is that correct?
Well, yeah.
Okay, so there are two different uses, which are in fact inconsistent, because there's a case where what you want from the input ports is basically a list of two ports, but what you are feeding to the function is varargs, two functions, right?
No, but this use case is still, we never really even thought of that.
Which use case?
This one that converts a list to vararg.
No, you have thought of that. That was the hack you were trying to pull off. That was exactly the hack you were trying to pull off earlier.
Can we maybe? I'm not super into this input ports. So maybe it's even useful. Can we quickly go through what are the possibilities that you can add to input ports? Because like this fact that 2 is 2 ports, but then you have shapes was a bit confusing.
Yeah, where's the specification of the ports?
A bit lower. Names, shapes, both.
Oh boy. Have we used this elsewhere?
In 12.2, that's currently being used in another layer.
Which layers?
Placeholder layer.
Where is exactly the grammar of these input port specifications?
But it's not yet there. It's 12.2.
I know.
It should be in threading layer, but we had recently some doc problems, but normally threading layer.
Okay, what exactly is the grammar?
So you can go to the threading layer doc page, and you will see what is currently in released versions. It's called inputs and not input ports, and it's not as flexible as that, but it's basically that.
Well, look, okay.
But otherwise, the way to use it is this. Either it's an integer for just specifying a number, or actually, yeah, you can see it here.
Inputs, number names, and their shape specification of input ports. But wait a sec. No, this is for 12.2, I think. This is DocuTools, is not the 12.1 version.
What are you talking about? Yes, of course, I understand that.
Okay, so you want to know about the new thing. So this is the new thing.
No, I don't want to know about. Look, listen. I want to know, what are you proposing for this input port specification?
That's
okay?
it.
That's it.
Okay. Now, what happens if you are giving? Don't you also want to give data types?
So in the framework, we have sort of it's a hacky way to.
No, but it's there. It's there. Just it should be written like names goes to shape. The last one. In the shapes, you can also specify the type.
Okay, so what we've been through before, okay, and you guys are trying to hack around it here, is...
I mean, this is already the case.
What you're trying to do, remember, the compiler has type specifications that don't care about the length of its lowest level, lengths of arrays. You
Yeah.
do care about the lengths of arrays,
Yes.
right?
Yep.
Okay. So what we need to do is get a merge specification that works for both the compiler and for this, that allows you to elide with automatic the length of the array in the case of the compiler. Did you see what I'm saying?
Like an extension.
And yet
of type-
again, you don't
type.
have anybody from the compiler group here. Is that correct?
We will have people from the compiler group in the next compiled layer meeting, so maybe that's the better place to discuss this.
Okay, but it's going to affect. Okay, so listen, coming back here. Okay, it's going to affect what is actually fed to that initial function. Do you understand what I'm saying?
Yes.
I keep on going over the same thing, right?
There's one
Go.
thing that you should know is that you can already specify a shape with the name of the port, right? Name of the port, arrow, the shape. And I believe Matteo and Jerome can confirm that you can already specify type as well. So there's already a spec that is used
Yes.
Where is
in the
that spec?
system.
And it's not new. It's since 11.
Yeah. So do you have an example,
It's a
Jerome?
total
you can
hack
show?
of some kind.
Well,
In NetGraph documentation should be the most complete for this.
So really what we're doing is just extending on this. We're not trying to,
Okay, so basically it's a hack. And it's probably the right thing to do something. I mean, eventually all this stuff is going to get redone. This was 5 years ago, whenever it was, more than that now. This was all intended as a preliminary thing. Because we knew that not enough was known about neural nets to make a final design.
Port goes to shape. You have this list, this
You can
table.
check the,
Where
you
is
can
it?
check the big table, the table at the bottom. Specifying the array shape, certain encoder, blah, blah, blah.
Okay, so now okay, so you were imagining something like that for function layer, correct?
Yes, because it's the same exact system that
Okay,
the
but
entire
now
framework
you have a
has.
new
all the
issue.
layers, all the layers.
Yeah, all
Right,
the layers.
but you have a new issue here, right?
Which
you have a
is-
new issue.
It's
which
several
is
ports.
what happens when, in this case,
It's the same
innards
for
of
NetGraph.
no, it's saying, in this case, in these cases, the innards of the layer can auto-magically interpret the port specification and decide what to do. In function layer, that cannot happen unless you have an intermediate processing layer. Do you see what I'm saying? You don't have the choice. Go ahead.
I don't get the difference between a function layer and NetGraph, for example, or attention layer, which is a layer.
I'll tell you what the
I
difference
think-
is. The difference is that in the case of function layer, you are feeding whatever you get out from processing the ports raw to the function, right? What you've tried to do is to hack the function so that it can see what it's getting from the ports and decide what to do. You can be successful at doing that if you completely control that function. You cannot be successful in doing that if the function is a user-supplied function.
Yeah. Jerome, Stephen is referring to compiled layer where you have a compiled function and you can get a bunch of information about it.
Okay.
Among other things, or attention layer, or any of these other things where you control what that function does.
Okay.
Right. By the way, I don't know why that bracket is expanded in size. Somebody should report that bug.
Yep, I got it.
By the way, what do we do for threading layer, Jerome? Because we also have this hash1, hash2.
No, but what do you mean? Yeah, we do the same. So now actually, it was extended for 12.2. That if you use a named slot in the function, that then it will give the name of the ports. And if you use a numbered slot, then it will be input 1, input 2, default names. Was it clear?
Look, the only choice here, okay, you have a totally hacky thing from this port specification. You're being bitten by that hack because you're trying to feed these things to a well-defined, user-defined function. Right? So how are we going to deal with this? So one way to deal with it is to have an intermediate processing step that somehow takes the hacky thing and turns it into something well-defined. Am I making sense?
Yeah. This hacky can become a deprecated syntax, and we can, we can be closer to compile, function compile.
Yeah, but we're not ready for that. You're not ready for that function compiler.
Yeah. Not for 12.2. Yeah, of course.
Right. So I would recommend that what you do here, I just forget about the hash1, hash2. Just say hash sub 1, hash sub 2. Sorry. And if you don't want to do that, wrap an apply around it. Because from the reason you don't want to do that is because you've got another layer of hackery going on, right? Which is you're actually going into the insides of that function and you're trying to convert it, right? You're essentially trying to do compilation. Is that correct?
Yes.
Right. So you've got another level of hackery. So I would recommend that you conflate the hackery and basically say, you just specify for people, if you want this thing with hash1, hash2, use apply, and then your compiler needs to recognize apply just like it recognizes a bunch of other things. Am I making sense?
Yes.
I think that's the best way to do it for right now. And then the input ports have this language, unbelievably complicated language. What on earth happens when you say varying here? What does it actually do? I mean,
it's variable length.
Why is that not called automatic anyway?
Because
automatic will infer it can be fixed and automatic, and it will be automatically inferred. But here you specify that it's variable, like each example can have a different length.
I see. So one of those should probably be called inherited and the other could be called automatic. But in any case, that's for the future. I mean, that's a different issue because that's something where this is essentially at runtime, this is variable, right? Is that correct?
Yes.
Yep.
Whereas at the other case, it's inherited at compile time. So arguably, the inherited case should be called inherited, and this case should be called automatic. Well, I'm not sure about that. But in any case, this...
Yeah, I mean, this is sugar, but yes.
Okay, so now what you've got here is a syntax, yet a different syntax from the one specified here. Is that correct or not?
It's an extension of that to several arguments, to several ports.
It's just a list of this.
Several ports. So, oh, I see.
You see at the beginning, you have port goes to shape, and this is the table for shape. This is just a list of ports.
Yeah, it's a list of that, basically. I mean, yeah, plus the rule version.
So I don't understand this case here. Oh, no, okay. So this case should surely be an association because those ports have to be distinctly named. Right?
There is, yeah. So we started from an association, but then we thought that maybe list of rules was a better idea because it has to do with compiled layer and with the fact that arguments in the compiled function are positional, and you can never use an association there. They're positional, and so to enforce.
What are you talking about? What are you talking about? It has nothing to do with that. I don't understand.
Let me explain. Let me explain what the reason is. The change from association to list of rules came from compiled layer, in which your functions only have positional arguments, and so
this is a hack. This is a hack. This is the same hack we've been talking about, right? What you've got to do is the actual function is being fed a processing of the things which are being pulled in from whatever the knitting is with this layer.
Yeah, I didn't want to make that comment a few minutes ago because it involves compiled functions which are more complex, and we don't have anyone from.
Okay, so hold on. Here, we don't have anybody from the compiler team, so we can't discuss it.
Exactly, but we will in
I know, but you're making a design here that is supposed to cover that case, right?
Was there another reason?
Association for that. I mean, everything we care about this now is whether to use association or list of rules, and
you should probably support both.
Association is still not. Oh, sorry.
Right.
So
look. Okay. Everything we're doing here. Okay. Hold on. This is a giant hack tower, basically, in the end. as most of these, I mean, look, the choice is you either just write code, which is what we had planned to do like 7 years ago or something when we started this, but we decided that layers were a better idea, which I think is fine for many purposes. It is less fine, you know, as, I mean, it's unclear to me. It's like what happened in linear algebra, where basically there are these random, you know, matrix decompositions that are very rarely used on their own. Rather, people create, you know, use some super function that's a combination of these things. And the question is, and, you know, for example, you know, something like LU decomposition, it returns its results in a fairly hacky form. It is the standard form for linear algebra, but it is nevertheless a fairly hacky thing. So the question is, similarly with these things where there's the innards of neural nets, it's not obvious. I mean, the fact that LU decomposition returns something which I would consider somewhat hacky, nevertheless standard in the linear algebra community, has never been an issue. In the very rare cases where you use the innards of what LU decomposition returns, you can just unpack it and, you know, and process it the way you want it. Why am I talking about this? Because I don't think this is ultimately the way we want to do this. I think this is something, you know, in the immature state, which is becoming more mature, of kind of neural nets as tools. Right. Okay.
I mean, I guess the point is that the language, the Wolfram language, is super expressive, and no net function will be as expressive as the Wolfram language. So we need at a certain point to cut and say, okay, we stop you here. And the compile layer is pretty obvious, and this one is maybe a bit hacky because it's not as clear.
Are you sure it shouldn't be called native function layer or something? I guess native function layer, you would expect to actually put native code inside it.
So
What does it do if I feed it a function? What's that?
Nature sounds a bit obscure to me.
It is obscure. This is very obscure because it's going to be a voyage of discovery to figure out what works and what doesn't.
I mean, we can, one thing that I know is a bit strange for our documentation, but I've always found extremely nice is that the element-wise layer and threading layer, for example, they explicitly list what they support.
Yes.
And this is...
we could refer to this list in the, or if we don't already do it actually, in the documentation of NetFunction.
Say that again.
If you click, you have a page here, you have a threading layer, for example. If you click on threading layer to open the ref page, you will see that threading layer also support a sub-syntax of a language, mainly math operations. And those are explicitly listed. So if we can support more, the list expands.
Where is it listed?
At the top, just below the syntax box.
Where?
So you have plus the third sentence, plus subtract times divide power. And this is, I mean, this is a bit cumbersome, but it's extremely clear to me as a user because I know already when I'm subscribing to this.
No, absolutely, absolutely. We should do that type of thing.
So the point is, like, if we want to give it a name, maybe the functionality here is like we take a much bigger subset of the Wolfram language than this list, and we convert it to network primitives, let's say.
Sorry, what's the difference between threading layer and function layer now?
I mean, it could be said.
Yeah, that's a good question. Like threading layer could be deprecated.
So,
okay, let's go back here because this is a hack removal meeting. Okay. Okay, so let's understand what we're actually trying to do here. And I don't even know what NetArray is, and I don't think it's going to make it.
Well, if there's no NetArray, we cannot create learnable parameters.
Sorry, what does NetArray do?
It represents an array that has parameters that can be learned by the
Okay, and where is it
when
going to be
trained.
used?
In NetFunction,
Which doesn't exist. It's function layer.
which in function layer, yeah, in function layer, and
How do you use it?
as a normal array. So you would create an array and then do operation on it, and that's it. Process with process it and so on. And we thought that we could combine it with net shared array and deprecate shared array, net shared array.
What is net shared array?
Net shared array, this thing that's allowed to share arrays in a network. So you give a name. It's a thing that I always found a bit hacky, but it's also because sharing array in graphs is not something super easy. In code, it's much easier. Actually, if you look at the way it's sharing in NetFunction here, you would just do something like that: array call NetArray or whatever, and then you put this array wherever you like, and they're shared. So net shared array is not about function layer, right? That would be useless from function layer. It's really in a graph or in a chain. You have to have this stuff that if you look at documentation.
No, look. I mean, the fact is, what you're doing is, in a case like this, where you say array equals, that becomes a shared net array because they're both assigned to array. If I use separately here, array23, array23, they will be unshared layers.
Exactly. Yeah. And this is a very natural.
Hold on. So then when it is trained, it is implicitly using the fact that those are mutable, those are identical mutable things. That is very hacky. Right? Because if I said A equals B equals net array of 2, 3, and then one of these I put A into and the other I put B into, you're toast. Do you see what I'm saying? Or it's very hard to know whether it's. Do you understand what I'm saying?
Be if we name automatically. So that was one of our ideas, is that every net array actually has a name automatically, and so even if you do something like that, it will still.
Well, actually, the worst case is this. What on earth does that do?
I mean, this will basically B will be a new net array every time you use it.
Exactly.
While A, it will be the first net array that was generated. So A could be equal to
no,
B.
it's much worse than that. And this actual thing will be much more crazy. But that's okay. Let me do it this way around. Then it will be. But I don't think any of these are the right thing. So what you're talking about is a net array. If you want a mutable net array, are you expecting that the net array will be addressable outside of your functions? Probably not. Do you understand what I'm saying? In other words, you could have a create net array which produces a net array with a UUID, and that net array with the UUID runs around just like a symbol, addressable from anywhere.
So you have array equal create net array?
Yeah, but not inside here. You can have it anywhere. That's one model for how to do this. It's just there's a mutable array object, which is like our expression object thing, which is still not implemented. I don't think it's the right idea. So what you want to do here is in this thing, you want to have an array that you refer to multiple times that is a mutable array. What else is mutable in here? I mean, in other words, in a custom, in a layer that is of internal design.
I mean, every layer is mutable.
I understand. Every layer is mutable, but what aspects of a function layer are mutable? You're not defining that. In other words, if I have a variable in a function layer, is it mutable? Is it not mutable? Do you understand what I'm saying?
Yes.
Now, what you're saying is the only things that are mutable in function layers are net arrays. True or not true?
I can answer this. Jerome? Do you know if there's any other thing mutable?
Jerome.
He doesn't have very good connection today. Sorry. But let's say that is yes.
Well, but we need a definitive answer to that question.
So what do you mean by mutable?
I mean, does it change when you train it?
That then I guess that's the only thing. Yes, I mean everything that is inside the layer and the net array.
I had some mic problems.
I'm sorry.
I have some mic problems. So yes, they are mutable and they can be.
No. We're asking, are the only thing that are mutable?
The net arrays?
Yes. In the function layer, are they the only things that are mutable or not? Say it again.
In the built-in layers, like linear layers, attention layers, there can be some
Okay, so there are mutable things there.
Yeah.
Okay. All right.
I mean,
so
like you could imagine that all the layers with parameters that are trained, you could write them with NetArray.
Okay.
Locally with NetArray.
Exactly. But
so
that's the wrong.
Linear layer is like a NetArray dot and the plus.
Sure.
With another NetArray.
I mean, that's writing everything explicitly in code, and we're doing halfway there, and that's not going to work. So I think the thing to do in function layer, if there is a particular, just like you've said, weights, arrow, blah, blah, blah here, right? What you want is in function layer, and Jerome has to actually be hearing this because otherwise he's the one implementing it. So in function layer, the basic point is that you have this NetArray thing, which is being referred to by things in the function layer. Is that correct?
Yes.
Right. So in a sense, now how many NetArrays could you have in the function layer? As many as you want, right? Is that correct?
Yes.
Okay. Each one effectively gets a name for purposes, and how can it be used? Could I say something like A equals NetArray blah, blah, blah squared? Would that work?
Should.
Okay. So explain to me, so can I have NetArray of 2, 3 equals? Can it be an L value?
Of 2, 3 equals?
I don't think that makes sense. I mean, this is very similar to image, yeah, which is a constructor, and then it holds something once it's been constructed.
Yeah, you're gonna put it on the left of something of an equal.
Actually, now that I think about it,
okay, but so,
the same way, yeah.
Say again.
Like image works.
Yeah, sure.
The similar way.
But image doesn't get updated. The issue is that during the operation of this function layer, the return after nettrain, the returned function layer is different from the function layer that was originally given. And in particular, the NetArray, which was abstract and symbolic in the original untrained function layer, is now something explicit. Am I right?
Yeah. I mean, it will be explicit as far as you initialize it, even before training.
Okay, so what does an initialized NetArray look like? If I say net initialize of NetArray, what do I get?
You could in principle get different initialization. I mean,
but in particular, if you say net initialize of NetArray, do you just get an array out? You just get a matrix out?
We decided last time that it would be not evaluated. It would still be NetArray.
Yeah, but it's not evaluating, but the object contains the value.
I'm sorry?
It won't evaluate. It will still be a NetArray, but
contain the value, so you should be able to query it.
Okay, so this isn't the correct syntax. So the correct syntax for NetArray is NetArray has its shape, and potentially it also has its values. Now that's presumably like linear layer has its shape, and it also potentially has its explicit weight matrix. Is that correct?
Yes.
You can look at constant array layer, which is something which is very close to NetArray.
Exactly.
It's NetArray now.
And actually, yeah, so for me, it will be the shape and either the values or an initialization method. Which could
we don't have constant array layer. What is constant array?
It's array layer on this version.
I'm sorry.
You have it, array layer, the first one.
The first one. We went through some iterations with the names, but yeah.
And probably should be called net array layer. So.
And also notice just a bug that doesn't have its preview.
Yep, I got it.
So we talked about it last time. This is just a renaming. But if we have NetArray, you said last time that maybe it should be called NetArray layer because it's exactly the same thing, except you have to do open bracket, close bracket to get some to be able to use it.
Well, NetArray, you cannot do weight sharing with array layer because it's a layer, so it's not exactly the same thing. They're very close.
Look, the sharing thing is a total hack. The sharing thing is some weird total hack that involves you going in and trying to notice certain patterns of variable assignment, and it's really not going to work.
No,
we think that is very, very neat, actually, because it's a very natural way to do it.
I know. Listen.
Very practical, yeah.
Listen. In the future, we should be able to take arbitrary code and essentially compile it to be used as a trainable thing with automatic differentiation and so on, right? But we are not there yet.
I mean, that's a side thing. The question here is how to define parameters that will be learned.
I understand that. But in a particular, very, circumscribed, set of functions, right? Because function layer only supports certain functions in here, right?
Yeah.
Okay. So one of the functions it supports is assignment.
Yeah.
For temporary variables, which is its alternative. It's essentially procedural programming way of representing what otherwise is done with essentially the graph connections of a net graph, right?
Exactly.
Yeah.
Okay. So this is, really we've got three styles of programming here. We've got functional, function applied to function applied to function. We've got, what has never happened, but I have thought about since the 1980s, and maybe have finally a way to do it recently, is functional programming, but where those functions are not being applied, f of g of h of whatever, but instead they are being their application is being represented by a graph. Does that make sense?
The sentence makes sense in English, but I cannot visualize it.
Okay. So what I mean is this. Okay, we actually had prototypes of this back in the early 1990s, but it was never useful enough to actually implement, right? So imagine we have a directed graph. So we have, let's say, what's a good example? This is I'm not doing a good job here, but I mean and this won't represent things properly. Oops. This is a bad representation of this. Okay, so this is a bad representation. Sorry. What I'm saying is f of g of x is represented by this linear graph here. Am I making sense?
Mm-hmm.
Yeah, you are mixing functions and variables on the same plane.
No, that's just. I just said. The point here is this. The point here is what you're doing with neural nets is you're saying, and you've got port numbers here. Look, the issue is how are you passing arguments, right, to what end up being functions that just eat some number of edges. Does that make sense? So every function has some number of edges coming out of it in order, in fact, which is something not readily represented in graphs right now. Do you understand what I'm saying?
Yeah.
Okay, so this is, and so what I'm saying is, like in tensor diagrams, like in many of these kinds of things, we could represent the composition of functions by a graph like this. This is also something that effectively the compiler is doing. It's also something where when you represent a piece of code this way, register allocation becomes graph coloring. That makes sense?
Yeah.
Yes.
And except that the graph can change on evaluation, but for one evaluation, you have one trace. Sort of, yeah.
Well, no, but I mean, the point is that we could write out right now. I mean, the naive way that we're writing this out is as a tree, right? I mean, if I say f of g of whatever it is, h of x and y, and but what this is not going to capture. Okay, so if I now say expression graph, so here's the thing this is not going to capture. It's not going to capture common sub-expressions.
Yeah. Like you would with a variable.
Exactly. Right. So the difference is that, in other words, were you to be able to give this, where it isn't a pure tree, it's just a DAG, right? The DAG, and this is what is done endlessly in Boolean function evaluation and a bunch of things with Boolean functions. I think, yeah. So, right. So, and the issue is, is there a DAG way to specify what would otherwise be an expression tree? Right. Actually, it's an interesting general problem, right? So, in other words, imagine an expression tree imagine an expression actually, it's interesting. This is an interesting general construct. A thing that is an expression constructor that does not use variables, but nevertheless shares things. And normally, one doesn't care so much because the sharing of things, if the structure is immutable, it doesn't really matter whether it's shared or not. That's just an implementation efficiency detail, right? The difficulty you're running into with neural nets is it isn't immutable. The thing is being trained. And the issue is, are two pieces of thing that are being trained locked together or not? Or are they separately hanging out as different branches of a tree? See what I'm saying?
Yeah.
Right. So the reason you're getting bitten here is, for the first time, what you're normally representing as an expression, in fact, has pieces that are really identical. Because normally, if I write f of g of x, those two g of x's, it's an implementation detail unknown to the user whether those g of x's are stored in the same piece of memory.
Yeah.
Right.
It's true.
Okay.
It's not for us.
What's that?
I mean, yeah, no, it's true. It's not. Yeah. No,
right.
it's
So
not
okay.
like
So
that.
the issue that you have here is you want those two net arrays to be tagged as being identical, right? And that's why you're thinking of this naming thing. Go ahead.
I mean, no, actually, the naming things was to solve this problem when you have a graph. So where you're going right there is to go back to the naming thing that we're using in graph. But the point in using more procedural type, more imperative or whatever type programming is that it makes this sort of things easier, at least for our brain, even though it's a bit hacky, doesn't really fit.
No, I understand. I got it. But the issue is, ultimately, this is going to be represented by some expression. After you've done all the procedural stuff here, right? It's going to become some expression. You could evaluate that to be an expression. So long as that expression has a way to represent sharedness, you're okay. Otherwise,
which is good with the naming. Yeah, you're right. If you have a UID for any net layer, NetArray that we create,
right?
Well, we're good.
Well, not quite, but we're getting there, right? So then what that's doing is that's saying, here are two things. It's still a little bit different because, okay, let me think about this for a second. I mean, if we have two symbols, right? The whole point is, okay, two symbols are known to be the same, right? You change them, they change together. Two other expressions, they only change if their value changes, but they don't change. There's no mutable. Let me think about this for a second. There's no way. Well, if I assign a value, if I say g of x equals whatever here, then on evaluation, something will happen. See what I'm saying?
Yeah, you have a side effect.
Yeah, but there's something different that's going on on training. There's no guarantee they're the same. In other words, given two things, yeah, you see, this is the case you've got. F of NetArray 7 or something, comma NetArray 7, or just for good measure, NetArray 8. Okay, are those the same NetArray or not? Are they being trained locked together or not?
Well, in this case, if you call a constructor twice, I would imagine as a user that this is creating two different things.
Yeah.
No, I understand that, but my point is that your way of doing that by using the fact that you're using a piece of meta information that is not guaranteed. That's the difference between equals and colon equals, right? You're using the fact that an equals. No, it's just wrong. It's just wrong. Look, the semantics of equals is you take the value at the time of the assignment and you put it in A, for example. That doesn't mean you take a value that is subsequently mutable and put it in A. That's the wrong thing. I mean, that's an abuse.
Yeah, but the value of an NetArray is an object, which is itself mutable. Is not an array.
I understand that, but the whole point is when you say A equals NetArray, B equals A, normally the semantics are B gets the current value of A. But what you're saying is, well, actually, it's not a current value. It's this weird thing that can be changed later. And that's different from what normally is the semantics of assignment.
Wait,
of immediate assignment.
Isn't the same like with entities? If I say like A equal dog and then B equal A, and then I change, properties are gotten from the server, so that's not different than training. Then when you ask the dog race, then you query for it, and it can change later. What you have assigned to A and B are just, is the mutable entity.
Well, it's an interesting, I give you credit for that being an interesting example. Yeah. The semantics of entities that change their values while you're doing a computation is an interesting one. Forced upon us by the world.
Yeah.
But very complicated. Like, how often do you refresh it? In the inner loop where you're using, the weight of a dog, which apparently might have been changed by the, International Dog Breeders Association or something, at the moment inside your code running, when is it cached, when is it not? That's a really complicated.
But this is actually an interesting point, because if I'm programming with entities, what I would do is I would query the property at the beginning and then just use the property as a value,
exactly.
not
Yes.
the entity as an object. And here the similarity is like if I don't extract the array from the NetArray, I keep it a NetArray with a name, NetArray dog. And NetArray dog is the same NetArray dog everywhere, and when I use it, I query its value at runtime, similar to what if I don't pre-evaluate the entity property.
Yeah. But okay, so let's come back to this. Okay. So the issue here is, so we've got two levels of issue. Okay. One is the incoming shape, which I think we've more or less handled with this input ports thing, but I think it has to be thought through carefully, knowing that we have no control. Once it is fed to the user function, it must be in the standard form for a user function. Make sense? Mm-hmm. Everybody agree?
Yeah.
Right? It can't have anything where it goes into the user function and says, aha, I can accept a different form. Okay, then the second question is, how do we have trainable arrays in the user function? Right? In other words, okay, what data in the user function is trainable? Okay, anything inside a layer in the user function is trainable insofar as that layer is trainable, correct?
Yes.
Okay, so the difference with NetArray is this sharing business. Because a layer, if I'm not mistaken, if I say, well, this is another question. If I say A equals B equals linear layer.
Yeah, they are two different linear layers. If you train A, you don't train B.
What? Are you saying if I say down here?
I think we would I mean, if you create A equal linear layer and you do a, I don't know, an edge chain of these two linear layer with referring with A.
So my question is, in that case, are you telling me that that's different from NetArray, from A equals B equals NetArray?
Should probably be the same.
Well, I think both are semantically troubled. Okay, so let's go through this again, okay? I think you have to decide whether, I think the unnamed but connected thing is just not going to work.
I mean, we can name everything. That was our, look, actually crazy idea, the third thing.
I saw.
That's exactly
Let's
that.
think about that. Let's think about it, because when you say, what you're saying is that the true form of NetArray is NetArray shape, comma, ID. And if you enter a NetArray without its ID, then it will be given an ID. And then subsequently, whenever you have this NetArray, when you use it, it will be a NetArray with an ID.
Mm-hmm.
Right? So in other words, if I say A equals NetArray of shape, what will actually be assigned to A, because of the semantics of immediate assignment, is a NetArray of shape, comma, ID.
Yeah. So
then your stuff, where you say B equals A, it's a happy thing. It'll just work.
Exactly.
Okay. So let's go through again what this means. So then, okay. So if I want to generate two, I think this will work. I think this will work. I'm a little bit concerned about it.
The only concern I have is the naming.
Which naming?
Like, how do you create the UID by default? And
well, just the one argument form is a fragile object which just UUIDs itself. The two argument form or whatever, maybe
it's UID, but you could have, in two sessions you create two things that happen to have the same UID, and then you load them together and then you join.
No, can't happen. It's an axiom of the universe that UUIDs never collide.
Okay. But yes, probably very rare.
No, it's an axiom that UUIDs will never collide. Because, in other words, that is, I mean, amusingly, in our actual physics model, effectively, you have to say that. There is this notion of identity, and it is axiomatic that no two sort of independently created atoms of space can be the same. They can be isomorphic, but they can't be the same. And amusing, but I think for practical purposes, the whole point of a UUID is it's long enough that it won't collide.
Yeah.
Right. So it's just taken for granted. So that means that every net array in every different session is different.
Mm-hmm.
So do you want A equal B equal linear layer to use a crazy idea?
Linear layer.
Should we at least investigate it? Like, is linear layer evaluating its net arrays inside, so it is fixed ID or not?
I mean, what have we done previously with linear layer? I mean,
no, we have done that. It's independent.
That they're independent.
Yes.
I think that should continue to be the default, unless for some, I don't think you can change that. I mean, I think you should think through that default, but I think you can't change that for what we've done so far. Now, okay.
Jérôme, didn't you say that Tally thought that it was a mistake, that we should have made them? Oh, Jérôme is gone. Okay. I think Jérôme told me a few hours ago, Tally was saying it was a mistake, that we should have made them be the same layer.
In the case of A equals B equals linear layer.
The point is that,
well, why don't you investigate whether it's possible to do that with these IDs? I don't think it should be an argument. I suspect it should be an option somewhere. Okay. And one thing you can do, much like we do for cryptography, is represent the you know, if I say encrypt, you know, foo. Oh, brilliant. Okay, so you get things like that, which are, I mean, that's a rather big one, but you understand that's a way of representing that colored weird thing. The main point is if I say, if I encrypt something else, right? I don't know what it is, but that is a representation of the encrypted bits. Do you see what I'm saying?
Mm-hmm.
And that's the same thing you could do in something like that is something you could do with these, with the display form of these ID'd linear layers, because you definitely don't want to see UUID blah 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 blah, but you do want to see, are these the same or not? Does that make sense?
You mean, yeah, to at glance know at glance if they are the same. Yeah.
Yep. It's
This
sort of
is
a
like
clever. What's that?
typesetting. This is a typesetting thing.
Yes, it's just a clever way to do that.
I guess we
Okay.
should investigate what are the tendrils of this. I mean, like, will it break everything? Will it break havoc in the framework if we change this thing?
Well, I know. You need to look at that. I mean, I don't think it will affect anything that already exists because you don't have assignments right now.
Well, people.
Well, maybe do in construction notebooks.
Exactly.
You have
Exactly.
Yeah.
I don't know what can be done. I don't know. You should look at it. But then the other thing is this sharing, this business, which I think we should talk about in a separate meeting, this business about the representation of shared sub-expressions in a case like this, which I think you're going to need. Right? This is a way around that by using IDs. But in the end, this is going to be something desirable. Make sense? All right, I just want to comment on some things on our live stream, and then I need to go. Oh, lots and lots of things here. I see. I still have to figure out how to pronounce this. I'm going to call it IC because I don't know how to pronounce it. I'm probably just being stupid. It probably spells something clever, but I don't see it. Okay, so IC was commenting about a guide for designing functions. Unfortunately, we have a few such things, but it's a difficult business. I mean, I've spent like 40 years learning this stuff. I'm not sure, you know, there are some principles which we have enunciated, and I don't know where we have. We used to have our design analysis group, which is since disbanded because basically different individual development groups all learned how to do their own design analysis. Used to have some list of these things. I wonder where it is. We should try to find it. Yeah, we should try to find this. Devin, that would be an interesting thing to try to find. I don't know whether it's out there on the web, but it is interesting. It's pretty obvious. I mean, it has a lot of obvious principles. Okay, next thing here. Comment from Sander about functions. That this case here, function, yes, it ignores subsequent arguments. In other words, it is, I remember thinking about this at great length 33 years ago or something. And yes, I mean, this was somewhat informed by what happens in lambda calculus. Yeah, it is what it is, not changeable anymore. Okay, let's see. Splice, Nick says, Splice should have a second argument for a head that it is allowed into Splice into. Yes, I firmly and completely agree. And let's put that back on an ILD agenda. The last time I raised that, I tried very hard to shoot it down, but I think it needs to ride again. it's a good idea. Actually, a pattern for what to splice into. Ethan is commenting, bigger issues that NetFunction is limited. Yes, we know that. Steve is saying import from TensorFlow. Yeah, and that's a whole complicated story of of changing standards for what this and that is. And what we're right now concentrating on is Onyx, which should allow us to be portable across many different frameworks. Yeah, Nick is commenting dynamic graph construction. Yes, we're aware. Yes, well, this is Nick is commenting NetArray with tensor algebra and surgery operations and auto differentiation. Yes, we're aware. And I mean, the same issue about tensor diagrams. Oh boy. Yeah, I mean, it's coming up in a lot of different places. It's coming up in our discussion about all of these array reduction kinds of things. It's also coming up in our ZX calculus stuff for the physics project. Yes, it is something. It is having its moment here. Ethan is saying, why not net variable? Yeah, right. Push is saying, why is it net array? Why is it not something which is why isn't that a more general construct? Okay, Ethan is talking about a graph of neural nets. Well, in a sense, a graph, that's what netgraph does. Transformer nets, Ethan put comments, are just graph nets. So I don't know, what is a graph net? What does that mean? As opposed to does it mean a net that operates on graphs? Anybody want to comment on that?
Nothing precise, but I know there's a lot of thinking about what transformer really is and trying to change the paradigm of how we should view neural networks.
To be something where they're operating not on arrays, but on graphs.
Yeah, including
I mean, the problem is it's going to be the same story as it's been from the beginning of this whole business, which is the more general, the less trainable. I mean, that's been although that story is beginning to decay as, more automatic differentiation becomes possible. But that was, for a long time, that was kind of the generic story. Trying to make propagation networks. Computation graphs with pointers, asynchronous calls, information propagation. That's interesting. Okay, I don't know what that is. Anybody know what propagation networks are? I think that, oh, I see. Yeah, okay. So this is like a generalization of the concept of spreadsheets, where there's one thing where it's immediate evaluation, and it's just a graph that represents a function. Look, I mean, gosh, this problem of graphs that represent functions, I'm embarrassed to say that I've been grappling with this problem since the late 1970s. And I think it's time to actually solve it. That is the duality between the parsing of, parsing values around and the propagation of information through graphs. And I think that the physics project story, which reveals how complicated that is with, where things can be parsed in parallel and so on, probably time to really solve that. It's guaranteed to be heavy lifting in terms of design. And it's also, if done correctly, it will provide an actual framework for doing parallel programming that with luck, might be understandable to humans. I mean, as opposed to what we're doing right now, which is, our quotes parallel programming is mostly array programming, which is understandable. You take the whole array, you do something to it. What we're doing as we do all this array reduction stuff is the first, the generalization of that is arbitrary parallel weird stuff going on that isn't just slicing arrays along axes and knitting them together and so on. Anyway, interesting stuff. All right. Okay. Sounds good. Oh, it's Steve is asking something about array of region of sphere. Spheres and balls are not the same thing. A ball is a filled-in sphere. A sphere is just the surface. Okay. All right. Anything else here?
I think we're good.
Okay. Thanks very much. Thanks to everybody on the live stream. In another hour and a bit, we will be continuing with a live stream about calculus and algebra features for 12.2. All right. See you all later.